Okay, class, today I'd like to review the slope, distance, and midpoint formulas using the coordinate geometry formulas that you had to memorize in class, as well as tying it to a graph. All right. So the question says, what is the slope of the distance, and the midpoint of line segment AB? Okay, and I'm giving you the two coordinates. All right. Now, for all of the coordinate geometry formulas, okay, you use the two x and y coordinates. So we are going to call this coordinate point x1, y1, x2, y2. All right, now, first let's find the slope formula. Okay, so the slope formula, I use the letter M because that signifies slope. We're going to find the slope of line segment AB. All right, now the formula relates to rise over run because that's what slope is. The rise relates to the rise along the y-axis, so we will call that y2 over y1. And then the run relates to the movement along the x-axis, so we're going to call that x2 minus x1. Okay, now let's find the slope using these coordinate points. All right, the y2 is 0 minus the y1, which is 4, over x2, which is 6, minus x1, which is negative 2. Be careful there because you do have a double negative. All right, 0 minus 4 is negative 4. 6 minus negative 2 is really the same as 6 plus 2 using the keep change rule. 6 plus 2 is 8, all right, and you do have to reduce this, especially when trying to tie any line segment into another one being either parallel or perpendicular. Okay, so negative 4 over 8 will reduce using a GCF down to negative 1/2. Okay, keep this number in the back of your mind. All right, the next formula is the distance formula. Now, distance, you know to do distance when the question says, what's the length of something? Okay, so the distance formula is a d. Okay, so we're going to find the distance of AB. Okay, now the formula is quite long. It relates to the Pythagorean theorem. Okay, so it's the square root of x2 minus x1 squared plus y2 minus y1 squared, which kind of relates to a squared plus b squared, and the last step of the Pythagorean theorem is always to take the square root when you're looking for a hypotenuse. Okay, now let's plug into the formula. You take your square root, your x2 is 6, minus your x1, which is negative 2, we're going to square that, plus y2 is 0, y1 is 4, and we're going to square that. Okay, now you definitely have to use your PEMDAS rules, which says to do everything inside parentheses first. Okay, so 6 minus negative 2 again really means 6 plus 2, which is 8 squared, plus 0 minus 4 is negative 4 squared, and then we bring down the square root. 8 squared, which means 8 times 8 is 64, plus negative 4 squared. Be careful if you're typing this into the calculator, make sure that you use parentheses. Negative 4 squared means negative 4 times negative 4, which is positive 16. Okay, bring down the square root, and then 64 plus 16 is 80. Okay, now for Common Core, you can leave that as the square root of 80. But if it's the integrated regions, most likely you are going to have to break that down using your biggest perfect square that does go into 80. The biggest perfect square that does go into 80 just happens to be 16. Okay, 16 times 5. All right, now the square root of 16, circle it. That's a perfect square. That will turn into a whole number of 4, and we will keep the irrational number of square root of 5. And that is the distance of line segment AB. All right, and the last thing that I'd like to review is the midpoint formula. Okay, so we're going to find the midpoint of line segment AB. All right, and that formula is just really just an average of the two coordinates, because when you're calculating the midpoint, it has to be directly in the middle of the two endpoints. All right, so it's an average of the two. So if we're averaging, we add and divide, right? Okay, so it's inside a big parenthesis because we're looking for a coordinate, and it's x1 plus x2 divided by 2, the average of the x coordinates, and y1 plus y2 divided by 2. Okay, it's the only formula where you're actually adding the coordinates together. Okay, just keep that in mind for answering any question. Okay, your x1 is negative 2, plus your x2 is 6 divided by 2, comma, y1 is 4, y2 0 divided by 2. So the midpoint has to be 4 over 2 and 4 over 2, which would reduce down to the coordinate point 2, comma 2. All right, now let's actually see this in its connection on the graph. Okay, so we're going to use the exact same heading. Okay, and we're going to take a look at this using graph paper. All right, so if we graph the coordinate points, okay, A we said was at -2, 4, which was right here in quadrant 2. Okay, let's label that A. And B is 6, 0. Now, always keep in mind, all right, this is your x-axis. Your x-coordinate here is 6. So 6, 0 has to be lying on the x-axis, which would be right there. Okay, so this is the line segment AB that visually, using a graph, we should be finding the slope, the distance, and the midpoint. Okay, now to find the slope, we talked about this before. Okay, the slope always means your rise over your run. Okay, now when you're running, you always want to run to your right. So you want to start at the coordinate point on your left so that you can run to your right. Okay, now are we going up or down to go to point B? Well, we're going down. How many are we going down? 1, 2, 3, 4. So I'm going to call that -4. And we're going to run to the right. 1, 2, 3, 4, 5, 6, 7, 8. And it kind of makes sense because that's what we came up before using the slope formula. -4 over 8, again, would reduce down to -1/2, which means that it's going down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Okay, now, the distance formula. Okay, if we need to find the distance formula, remember the distance formula relates to a squared plus b squared equals c squared? Well, what do you see in the picture here? Well, I kind of see a straight line for my line segment, and then using that slope, I kind of see a little triangle being formed here. What type of triangle? Well, it's a right triangle. Okay, with that being right there. Now, distance, you can't count boxes diagonally. So your only option is to create a right triangle. This vertical distance right here, okay, would be a vertical distance of 4. Counting boxes using my dots from before, my horizontal distance is 8. And to calculate the length of line segment AB, we could do a squared plus b squared equals c squared. All right, which would be 4 squared plus 8 squared. Remember, the a and the b are interchangeable because they are the legs of the triangle. And then I could keep the c squared if I really wanted to, or you could replace it with an x. 4 squared is 16. 8 squared is 64. Add them together, you get 80, which is exactly what we came up with before when you take your square root of 80, and then using the same philosophy as before, breaking down the square root of 80, using radical 16 and radical 5 would give you a distance of 4 radical 5 for the length of AB. Last thing I want you to visualize here is your midpoint of line segment AB. Now, your midpoint is just the point in the middle. Now, if you just do the eyeball test, it kind of looks like this point right here is in the middle. Now, if you don't see that, you can use your slope to figure out what would be in the dead center. Okay, so the slope was reduced down to -1/2, right? So if we follow that pattern, down 1 to the right 2, 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 we did that twice. Okay, now if you do that twice, that should be your midpoint in the dead center, which would be the coordinate point 1, 2, 1, 2. Thanks for tuning in, and next time we'll do another review lesson. Thank you.